Hi everyone, welcome back to PolyCloud YouTube channel. In this series, we are learning everything you need to become a Red Hat certified system administrator, that is RHCSA. Whether you are just starting with Linux or preparing for certification exam, this video will guide you step by step, completely free of cost. In this complete series, we will cover understanding and using essential Linux tool, managing software and system services, configuring storage and file system along with managing user group and network and security and a lot more. Everything will be explained clearly with hands-on demos. This is 100% free end-to-end learning series, and I will bring many more such courses on Linux, Azure and cloud technology in coming months. So please support the channel by subscribing and helping us to reach our first 1000 subscriber goal. It really motivates me to keep creating free learning content for you. Currently, Azure 104 series is going on the channel, and also this Red Hat series is going on. So let's get started and master Linux one topic at a time right here on PolyCloud.
Welcome to this course on analyzing servers. This course will teach you how to monitor system performance, identify resource issues, and troubleshoot common problems on Red Hat Enterprise Linux servers. You'll gain practical skills to manage services, handle unresponsive processes, and maintain overall system stability in real-world environments. In this course, we will explore how to analyze system load, CPU usage, and memory consumption using essential Linux commands. Next, we will show how to check disk space, manage running services, identify and terminate unresponsive processes, and detect potential system blocks. Finally, we will learn how to verify and repair software packages and access system support information. In this demonstration, we'll check system load and CPU usage using various commands in Red Hat Enterprise Linux. You need to open the terminal. So click on the Activities tab at the top left corner of the screen. Navigate to the options displayed below. Click on the terminal icon located on the right. This will open the terminal window. First, type the following command in the terminal. Uptime. This command displays the current time, system uptime, number of users logged in, and the system load averages for the past 1, 5, and 15 minutes. Press Enter to execute the command. The output displays the system time as 11:38 a.m., an uptime of 1 hour and 32 minutes, and 2 users currently logged in. The load averages 0.01, 0.00, 0.00 indicate minimal CPU usage, suggesting the system is operating efficiently. Let's clear the terminal once again for a clean workspace. Next, type the following command in the terminal. Top. This command displays real-time information about active processes, including CPU usage, memory usage, and other performance metrics. It's useful for monitoring system performance and spotting resource-heavy tasks. Press Enter. In the output, you'll see a table of processes with details, such as PID or process ID, for example, 2005. User. The user running the process, for example, root. PR or priority value, which in this case is 20. VIRT or virtual memory usage, such as 4,083,224. And many other columns showing process status and usage. Common processes you might see include GNOME Shell, systemd, and others depending on what's running on your system. To exit top and return to the terminal, press Q on your keyboard. Let's clear the terminal once again. Now type the following command in the terminal. vmstat 25. The numbers 2 and 5 enables the command to display system statistics every 2 seconds for a total of 5 updates. This command provides real-time statistics on memory usage, CPU activity, and other key performance metrics. Press Enter. You'll see the first update immediately, followed by 4 more updates at 2-second intervals. Each update includes a range of system performance metrics, such as procs or process information, memory, swap, I/O, system, and CPU. Let's clear the terminal once again. Next, we will use the mpstat command. If mpstat is not already available on your system, install it by typing dnf install syststat-y. Then press Enter. In the output, You may see a message indicating that the sysstat package is already installed and all dependencies are resolved. If it isn't installed, this command will automatically download and install it for you. Let's now clear the screen. Now type the following command in the terminal. mpstat -P, all in capital letters. Here in this command, -P specifies which CPU to display. All display statistics for all processors individually. Then press enter. In the output, you'll see username, for example, John, the current date and system time, a detailed breakdown of CPU usage for each processor, showing how system resources are being utilized. Let's clear the terminal once again. Now let's demonstrate historical CPU usage. This requires the sysstat service to be enabled. On most systems, if sysstat is installed, the service is enabled by default. If it isn't, you'll need to enable it manually. Once the service is active, type sar-u 13. In this command, sar displays system activity reports. -u displays CPU usage statistics. 1 and 3 means the data is collected every 1 second for a total of 3 updates. Press enter. The output will display 3 CPU usage reports, each recorded at 1-second intervals. Each report includes metrics like user time, system time, idle time, and other CPU usage statistics. These are usually shown with a percentage symbol, which stands for percentage of CPU time spent in each category. After the 3rd update, the command shows an average of the readings at the bottom. Let's clear the terminal once again. To display the current CPU usage for each process, type ps-e o PID, ppid, cmd, %mem, %CPU -sort equals %CPU, insert pipe operator, then type head. In this command, ps-e lists all processes running on the system. -o PID, ppid, cmd, %mem, %CPU specifies the output columns. PID or process ID, PPID or parent process ID. CMD displays command used to start the process. %mem indicates percentage of memory used by the process. %CPU indicates percentage of CPU used by the process. -sort equals %CPU sorts the output by CPU usage in descending order. Pipe head shows only the top results where default is 10 lines. Press enter. The output will list the processes consuming the most CPU resources at the top, along with their PID, PPID, memory usage, and CPU usage percentages. This gives you a quick overview of the most CPU-intensive tasks currently running. And that concludes our demonstration on checking system load and CPU usage using various commands in Red Hat Enterprise Linux. In this demonstration, we will perform memory analysis using various commands. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. Let's start by checking system memory usage. In the terminal, type the following command: free-h. Here, free displays memory usage statistics. -h makes the output human readable. Press enter. In the output, you'll see MEM and swap sections, columns showing total, used, free, shared, buffer, or cache, and available memory. For example, total memory is 3.6 GB for MEM and 2.0 GB for swap. Used memory for MEM is 1.5 GB. Shared memory for MEM is 29 MB. Available memory for MEM is 2.1 GB. Now clear the terminal screen. To view detailed memory statistics, type the following command in the terminal: cat/proc/meminfo. Here, cat is used to read the file. /proc/meminfo is the virtual file that contains real-time memory information. Press enter. In the output, you'll see low-level memory details such as MEM total is 3,743,476 kilobytes. MEM free is 1,678,272 kilobytes, along with other stats like buffers, cached memory, and swap usage. This display gives you in-depth insight into how memory is allocated and utilized. Clear the screen to continue. To find the processes consuming the most memory, type the following command in the terminal. ps aux sort equals percentage MEM insert pipe operator, then type head -10. Here, ps aux displays all running processes. Sort equals percentage MEM sorts them by memory usage in descending order. Pipe operator head -10 limits the output to the top 10 entries. Press enter. In the output, you'll see the top 10 processes sorted by memory consumption. For example, the highest usage is 10.6% by /usr/bin/genome-shell. Clear the screen again. To view the memory map of a process, type the following command in the terminal. pmap1. Here, pmap shows the memory map of a process. 1 is the PID or process ID, typically belonging to the system's init or systemd process. In the output, you'll see the memory segments used by the process, including details like read, write, execute permissions, associated file or service names, and memory addresses. Let's clear the terminal screen for a fresh view. To check kernel slab cache usage, type the following command in the terminal. Slab top. Press enter. This command displays real-time information about the kernel's memory usage for internal object caching, including cache name, number of active objects, total objects, memory used. It's helpful in diagnosing kernel-level memory usage. Press Q to exit the display. To check swap usage, type the following command in the terminal. Swap on --shell. Press enter. This command displays a list of active swap partitions and their usage details. In the output, you'll see name, for example, /dev/dm-1. Type as partition. Size is 2 gigabytes. Use and prio fields also indicate how much is being used and its priority. This confirms that the swap is active and functioning. Now clear the terminal for the next step. To list available huge pages, type the following command in the terminal. cat/proc/sys/vm/nr_huge pages. Here, the path /proc/sys/vm/nr_huge pages points to the system file that shows how many huge pages are currently allocated. Press enter. In the output, you'll see a number, for example, 0. This means there are currently no huge pages available on this system. And that concludes our demonstration on memory analysis using various commands. In this demonstration, we'll analyze disk space and I/O or input-output statistics in Red Hat Enterprise Linux. To begin, open the terminal. Click on the Activities tab in the top left corner of the screen. From the options displayed, locate and click the terminal icon on the right. The terminal window will now open. Let's begin by checking disk space. In the terminal, type df-h. In this command, df displays information about disk space usage. -h formats the output in a human-readable form. Then press enter. The output will show total disk space, used space, and available space for each mounted file system. Now clear the terminal for a clean workspace. Next, we'll check disk space usage by directory. In the terminal, type du-h/var/star. Here, du displays disk usage of files and directories. -s shows only the total size for each argument. -h formats the output in a human-readable way. /var/star specifies the /var directory and list sizes for each item inside it. Then press enter. The output will display a list of subdirectories inside /var along with their sizes. This helps identify which directories consume the most space. Let's clear the terminal once again. Now let's check the I/O status using the iostat command. Before running this command, ensure the systat package is installed on your system. If it's installed, type iostat-x-z15. Here, -x shows extended statistics for each device. -z omits devices with no activity. 1. Updates the output every 1 second. And 5. Runs for a total of 5 updates. Press Enter to execute the command. The first output shows detailed initial statistics, followed by updated summaries every second. These include CPU usage, device throughput, I/O wait time, and other performance metrics for storage devices. Let's clear the terminal once again. Next, we'll view real-time disk I/O usage using the iotop command. First, make sure the iotop utility is installed. To install it, type sudo dnf install iotop-y. If iotop is already installed and all dependencies are resolved, you can skip this step. Let's clear the terminal once again. Once installed, type the command sudo iotop and press Enter. The iotop tool displays real-time disk I/O usage for each running process. It must be run as root. Since we're already in a root terminal session, no extra privilege escalation is needed. To exit iotop, press Q. Let's clear the terminal once again. To monitor disk read and write activity, we'll use the dstat command. If dstat is not installed, type sudo dnf install dstat-y and press Enter. If it's already installed, you can skip this step. Let's clear the terminal once again. Once installed, type dstat-d y. Here, -d displays disk I/O statistics. -n displays network statistics. And -y displays system-level statistics. Press Enter to execute. This will display real-time statistics for disk, network, and system I/O activity. To stop the output, press Ctrl-C. Let's clear the terminal once again. Next, we'll view block-level I/O statistics. Type cat/sys/block/sda/stat. In this command, cat displays the contents of a file. /sys/block/sda/stat is the path to the kernel-provided file containing real-time I/O statistics for the SDA disk. Press Enter. This retrieves raw data values directly from the kernel, including read or write counts, sectors processed, and timing metrics. Let's clear the terminal for a clean workspace. To list all mounted file systems in a readable format, type mount, insert pipe operator, then type column-t. In this command, mount displays all currently mounted file systems. Pipe sends the output of the mount command to the next command. Column-t formats the output into neatly aligned columns. Then, press Enter. This displays all mounted file systems in a clear, well-structured format, showing details such as read and write permissions, file system type, such as proc or ext4, and their mount points. And that concludes our demonstration on analyzing disk space and I/O or input-output statistics in Red Hat Enterprise Linux. In this demonstration, we'll inspect running services and targets in Red Hat Enterprise Linux. To begin, open the terminal. Click the Activities tab at the top left corner of the screen. From the options displayed, locate and click the terminal icon on the right side. This will open the terminal window. Let's begin by listing all the currently active services. Type the following command in the terminal. systemctl list-units -type equals service -state equals running. Here, systemctl is the command to interact with the systemd service manager. List-units lists all active units on the system. -type equals service filters the list to show only services. -state equals running displays only services that are currently active and running. Press Enter. The output will display a list of active services along with their status and description. If the list is too long, you may see a message like lines 1 to 33 at the bottom indicating that not all results fit on the screen. Use the up and down arrow keys to scroll through the list. To stop viewing the output, press Ctrl+C. Now let's clear the terminal for a clean workspace. Next, let's check the status of a specific service. Type the following command in the terminal. systemctl status sshd. In this command, status displays detailed information about the service. SSHD is the name of the open SSH daemon service. You can replace SSHD with the name of any other service you want to check, such as FirewallD, HTTPD, or any other installed service on your system. Then, press Enter. Since we're checking the status of the open SSH server daemon, the output will show that the service is active, running, and enabled on the system. Let's clear the terminal once again. To view all services, whether active, inactive, or failed, type the following command. systemctl list-units --type equals service. In this command, list-units lists all active units on the system. --type equals service filters the list to show only services. Then press Enter. This displays a complete list of services, including active services, inactive services, and failed services. For example, MCE log.service may appear as failed and be highlighted in red. To exit the list view, press Ctrl+C. Let's clear the terminal once again. To check the current default target of the system, type systemctl get-default. Here, get-default displays the default target the system boots into. Press Enter. The output will show whether your system is set to graphical.target that boots into a graphical user interface, multi-user.target that boots into a non-graphical multi-user command line environment, or another custom target. For example, in this case, the output displays graphical.target, meaning the system starts with a GUI. Let's clear the terminal once again. Now let's view all available targets on the system. Type systemctl list-units --type equals target. In this command, list-units lists units currently loaded in the system. --type equals target filters the list to show only target units. Press Enter. The output will display a list of active targets currently loaded on your system. To exit the list view, press Ctrl+C. Let's clear the terminal once again. If you want to view details about a specific target, such as the multi-user target, type systemctl status multi-user.target. Then, press Enter. This will display the status of the multi-user.target, confirming that it is active and loaded on the system. The output also shows the location of its unit file, /usr/lib/systemd/system/multi-user.target. Let's clear the terminal once again. To view all the services linked to a specific target, type systemctl list-dependencies multi-user.target. In this command, list-dependencies lists all dependencies for the specified unit. Multi-user.target is the target whose dependencies we want to view. Then, press Enter. The output displays all dependencies and services associated with a multi-user target. Red entries, for example, MCE, log.service indicate inactive or failed services. And green entries, for example, modemmanager.service, indicate active and enabled services. To exit the view, press Ctrl+C. And that concludes our demonstration on inspecting running services and targets in Red Hat Enterprise Linux. In this demonstration, we will identify and terminate problematic processes in Red Hat Enterprise Linux. To begin, open the terminal. Click on the Activities tab at the top left corner of the screen. From the options displayed, locate and click the terminal icon on the right side. This will launch the terminal window. Before we begin, let's check memory usage by processes so we can identify any problematic ones. Type the following command in the terminal. ps aux-sort equals %mem. Insert pipe operator, then type head. In this command, ps displays information about active processes. AUX shows all processes with detailed information. Dash dash sort equals dash percent MEM sorts processes by memory usage in descending order. Pipe head displays only the top entries. Press Enter to execute. This will display the top memory-consuming processes. If you notice any process using unusually high memory, make a note of its PID and other details. Let's clear the terminal for a fresh workspace. Now press the up arrow key on your keyboard to retrieve the previously used command. Replace %MEM with %CPU to check CPU usage instead. So the command becomes PS AUX dash sort equals dash percent CPU pipe operator head. Then press Enter. This will display the top CPU consuming processes. If the system is facing performance issues, they will be reflected in the output. Let's clear the terminal once again. Sometimes system errors or slowdowns are caused by high memory or CPU usage. If you suspect the SSHD process is consuming too many resources, you can locate it by name using the pgrep command. Type pgrep SSHD. Press Enter. This will return the process ID or PID in the output. For example, you might see 914, indicating that the SSHD process is running with PID 914. If you want to check another service, such as Firefox, replace SSHD with the desired service name and run the command to obtain its PID. Let's clear the terminal once again. Now to get more details about SSHD process, type PS-p 914-o PID, PPID, CMD, %MEM, %CPU. In this command, PS displays information about running processes. -p 914 specifies the process ID, which in this case is 914 for SSHD. -o PID, PPID, CMD, %MEM, %CPU defines which details to display. PID or process ID, PPID or parent process ID. CMD displays the command used to start the process. %MEM indicates the percentage of memory usage. %CPU indicates the percentage of CPU usage. Then, press Enter. The output will show detailed information about the SSHD process, such as process ID 914, parent process ID 1, command SSHD, path /USR/SBIN/SSHD, memory usage 0.2%, and CPU usage 0.0%. Let's clear the terminal once again. If this process is causing unexpected behavior, you can terminate it using the kill command. Type kill 914. Here, 914 is the process ID of the process we want to terminate. Press Enter. If the command runs successfully, there will be no output. This means the process has been terminated. However, if the process doesn't terminate with the standard kill command, you can forcefully terminate it by typing kill -9 914. Here, -9 specifies the signal to forcefully stop the process. 914 is the process ID of the target process. Press Enter. Since we already terminated this process earlier, the output now shows a message indicating that the process with ID 914 does not exist. Let's clear the terminal once more. Now, if you want to terminate all running instances of a program, use the pkill command followed by the application name. For example, to terminate all Firefox processes, type pkill Firefox. You can replace Firefox with the name of any other application you wish to close completely. Press Enter. If the command runs successfully, there will be no output displayed, which means the application has been entirely terminated. And that concludes our demonstration on identifying and terminating problematic processes in Red Hat Enterprise Linux. In this demonstration, we'll analyze SE Linux denials to identify access blocks in Red Hat Enterprise Linux. To begin, open the terminal. Click the Activities tab at the top left corner of the screen. From the options displayed, locate and click the terminal icon on the right. This will launch the terminal window. We'll begin by filtering SE Linux denials for a specific process or command. Type the following command: AU search -m small avc -small c nginx. In this command, AU search searches audit logs for specific events. -m avc filters results to show only AVC or access vector cache denials. -c nginx displays denials related to the nginx process. You can replace nginx with any other service name, such as SSHD, HTTPD, or another process you want to investigate. Press Enter. As you scroll through the output, you will notice details such as type equals proctl. This shows the command or process that triggered the event as recorded by the audit system. It also includes a long encoded string representing the process. Type equals path provides information about file paths involved in the event. Item equals 0 indicates the first file path referenced in the event. Name equals /var /log /nginx /error.log displays the full file path along with its inode number, for example, 59756. Name type equals normal specifies the file type. PID equals 17,749 shows the process ID related to the event. This output helps you quickly filter SE Linux denials by specific processes or commands. Now let's clear the terminal for a clean workspace. Next, we'll use the SE alert command to obtain a human-readable explanation of the SE Linux denial. Type the following command in the terminal: SE alert -a /var /log /audit/audit.log. In this command, SE alert analyzes SE Linux audit logs and explains denials. -a specifies the file to analyze. /var /log /audit/audit.log is the SE Linux audit log containing recorded denials. This command scans the audit log and produces clear, user-friendly messages that explain why SE Linux blocked a specific action. Press Enter. You'll see the analysis begin with a completion percentage displayed on screen. If you scroll through the results, you'll notice a section indicating detailed audit information is available. The plugin reporting 100% confidence in identifying the issue. A message like, if you believe that nginx should be allowed associate access on the error.log file by default, then you should report this as a bug. You can generate a local policy module to allow this access. This makes it easy to understand exactly why SE Linux denied a specific action and how you might address it. Let's clear the terminal once again. Now to manually view the audit logs, type /var /log /audit/audit.log. Here, less opens a file in a scrollable view without editing it. /var /log /audit/audit.log is the location of SE Linux audit logs containing detailed denial messages. Press Enter. This command allows you to browse through raw AVC or access vector cache denial messages. These entries are often marked with AVC:"denied" in the log output. Use the arrow keys to scroll up or down and locate denial entries. You may notice details like message type, for example, daemon_start, source audit, additional data, such as process IDs, file paths, and access types. When you're done viewing the log, press Q to exit less. If you suspect that SE Linux might be causing an issue, you can check its current mode by typing Git enforce and pressing Enter. If the output displays enforcing, SE Linux is actively blocking actions, and you'll see denial messages in the logs. If the output shows permissive, SE Linux is only logging denials without blocking the actions. In our case, the mode is permissive, which means SE Linux is not actively blocking anything. So if you still see AVC denial messages in the logs while in this mode, they're being recorded for reference only, and SE Linux is not the cause of the issue. And that concludes our demonstration on analyzing SE Linux denials to identify access blocks in Red Hat Enterprise Linux. In this demonstration, we'll verify and repair installed packages in Red Hat Enterprise Linux. To begin, open the terminal. Click the Activities tab at the top left corner of the screen. From the displayed options, locate and click the terminal icon on the right. This will open the terminal window. First, let's verify the integrity of all installed packages. In the terminal, type the following command: RPM-V small a. Here, RPM is the package manager command. -V tells it to verify, and -small a means all installed packages. Then, press Enter. This command will scan all installed packages of integrity issues. The process may take some time, so please be patient. As it runs, you'll see file paths with flags next to them indicating their status. For example, a dot means no changes detected, everything is okay. It means the file mode or permissions have changed. 5 indicates an MD5 checksum mismatch. S means file size mismatch. G means group ownership changed. If you want to stop the scan at any time, press Ctrl+C. This is how you verify the integrity of all installed packages on your system. Now let's clear the terminal. To verify a specific package, type the following command: RPM-V HTTPD. In this command, -V stands for verify. HTTPD is the package name. Then press Enter. If there is no output, it means the HTTPD package is fully verified and has not been altered. Now let's try verifying a package that is not installed. Type the following command: RPM-V SSHD. Then press Enter. In the output, you'll see an error message because the SSHD package is not installed on this system. To verify a package, it must first be installed. Let's clear the terminal for a fresh start. Now to find out which package owns a specific file, especially useful if the file seems corrupted, type the following command: RPM-q-f/usr/sbin/httpd. In this command, -q stands for query. -f specifies the file. Then press Enter. The output shows which package owns the file. In this example, the file belongs to the package httpd://2.4.62-4.el9.x86_64. Clear the terminal again. To repair a package, you need to reinstall it. Type the following command: DNF reinstall httpd. In this command, DNF is the package manager. Reinstall tells it to reinstall the package. HTTPD is the package name. Press Enter. During the process, you'll be prompted to confirm by typing Y for yes or N for no. Press Y to proceed. This command reinstalls the HTTPD service without removing its configuration files. It restores any missing or corrupted binaries while preserving your existing settings. Once the reinstallation completes, you'll see a confirmation message indicating the HTTPD service was reinstalled successfully. Let's clear the terminal now for a fresh start. Now let's compare the installed files with those provided by the HTTPD package. Type the following command: RPM-q-l httpd. Here, -q queries the package. -l lists all files installed by the package. HTTPD is the package name. Press Enter. This command displays all the files installed by the HTTPD package. It's useful for manually verifying and comparing these files with those on your system to ensure everything is consistent. Let's clear the terminal for a fresh view. To view the list of configuration files for a package, type the following command: RPM-q-c httpd. Here, -q queries the package. -c lists configuration files. HTTPD is the package name. Press Enter. This command displays all configuration files installed by the HTTPD package. For example, you'll see the main Apache configuration file, httpd.conf, and other modular configuration files located in /etc/httpd/conf.modules.d/. This is especially useful when you need to review or modify Apache settings. And that concludes our demonstration on verifying and repairing installed packages in Red Hat Enterprise Linux. In this demonstration, we'll generate an SOS report to collect detailed system support information in Red Hat Enterprise Linux. To begin, open the terminal. Click the Activities tab at the top left corner of your screen. From the options displayed, click on the terminal icon on the right. This will open the terminal window. First, let's ensure that SOS is installed on our system. SOS is a diagnostic and troubleshooting tool used to generate detailed system reports. To install it, type the following command: sudo dnf install sos-y. Then press enter. In the output, you may see that the SOS package is already installed and all dependencies are resolved. If it's not installed, this command will download and install it so you can generate SOS reports. Let's clear the terminal now for a clean workspace. Now to generate an SOS report, type the following command: SOS space report. Then press enter. You'll see the SOS report version number in the output, like version 4.9.2. During the initial setup, you'll be prompted to press enter to continue or Control-C to cancel. Go ahead and press enter to proceed. As the report is generated, you'll see messages such as setting up archive and setting up plugins. These mean the process has started successfully. Keep in mind, this may take a few moments as the tool collects system data and generates the report. SOS collects system logs, configuration files, and other diagnostic information into a single compressed archive. You may also be asked to enter a case ID or contact information. These are optional. If you have a support case number, you can enter it here. At the end of the process, you'll see confirmation that all plugins have been installed and the data is saved in a compressed archive, ready for troubleshooting or support. Once the report generation is complete, you'll see details such as the file size. In this case, 12.75 megabytes. The file owner, which is root, and the hashing algorithm used, typically SHA-256, followed by a long string of hash characters. The SOS report is saved as a compressed archive at this location: /var/tmp/SOS report -John-2025-07-30-VLSSEKC.tar.xz. Clear the terminal screen. One important note: the old command, SOS report, without a space, is deprecated starting with Red Hat Enterprise Linux 9.6. So always use the new command with a space, like this: SOS space report. Now let's clear the terminal for a fresh workspace. Now to generate the report in non-interactive mode, type the following command: SOS report --batch. In this command, the --batch option tells the tool to skip all interactive prompts and generate the report automatically. Press enter to execute. You'll see the report generation begin, with system data being collected over the next few minutes. For demonstration purposes, instead of waiting for the full report, press Control-C to stop the process. When you do, you'll see a message like exiting on user cancel. This means the process was manually interrupted. Now let's clear the terminal for a clean workspace. Next, we'll include or exclude specific plugins when generating the report. For example, to include only the network and system plugins, type the following command: sudo sos report --only -plugins network system. In this command, -only -plugin specifies which plugins to include. Network system lists the plugins separated by a comma. Then, press enter. If you specify a plugin that doesn't exist on your system, you'll see a warning message indicating a non-existent plugin was requested. In such cases, verify the plugin names or choose valid ones from the available plugin list. Now let's clear the terminal for a fresh start. Now if you want to exclude a specific plugin, such as containers, use this command: sudo SOS report --skip -plugins containers. In this command, --skip -plugins tells SOS to exclude the specified plugin. Containers is the plugin we want to skip. Then press enter. You'll be prompted to press enter to continue or Control-C to cancel. Press enter to proceed. During report generation, you'll see messages like setting up archive and setting up plugins. This means the process is underway. Since we use the skip flag for the containers plugin, data related to containers will be excluded from this report. If you don't want to wait for the full report, you can press Control-C anytime to cancel. And that concludes our demonstration on generating an SOS report to collect detailed system support information in Red Hat Enterprise Linux. In this course, we thoroughly demonstrated how to analyze system load, CPU usage, and memory consumption using essential Linux commands. We then demonstrated checking available disk space, managing running system services, identifying and terminating unresponsive processes, and detecting potential system blocks. Finally, we demonstrated verifying and repairing installed software packages and accessing essential system support information.